everyone, and welcome back to SQL Squared, where we chat about all things data development and the cool tech shaping our world. As we know, we love bringing on awesome folks to share their stories and insights in the world of data. Today, I'm absolutely thrilled to be joined by Alex Merced. Alex is the head of DevRel at Dremio, renowned tech educator, and the author of several books on Apache Iceberg and lakehouse technologies. Welcome to the podcast.
Thank you so much. Thanks for having me, David. I'm really excited to be on. If you can't be excited about talking about lakehouses and data, what can you be excited about talking about?
Yeah, exactly. Maybe the World Cup that's on at the moment. Maybe that's what to be excited about.
That's right. That is happening.
All right. Well, in today's episode, we're going to be taking a deep dive into open source data engineering as a topic. We're breaking down the Apache Software Foundation and exploring the technologies like Iceberg, Arrow, and Polaris. Plus, we'll get into Alex's journey of writing technical books and building data communities. So let's get straight to it. Just with that last point on data communities, I know that you run a community called Data Lakehouse Hub. Is that right?
Correct. Yep. Basically, I run a website, datalakehoushub.com, which does have a Slack community, which I encourage everyone to join. I like to think of it as just like a vendor neutral place where everyone can talk to each other within the data space. So if you don't want to do a Slack connect between your event, your corporate account and their corporate account, you can always just all join Data Lakehouse Hub and chat there. But we definitely have conversations about data lakehouses, data, increasingly about AI as everything's kind of converging. But overall, it's just a place to learn and hang out.
That's good. Yeah, I've visited it over the last couple of weeks. I haven't made any posts or talked to anyone yet, but yeah, looks like a nice area for people to get together and discuss things. And I hope to create a similar community, a similar structure for SQL Squared as well in the future. So it's been giving me a lot of hints.
Yes.
On what to do. So, I mean, I suppose the types of things that you talk about in Data Lakehouse Hub and your various other books and talks and things that you do is Apache technologies. I mean, we met at SQL Bits over in Newport back in April, I believe it was April.
Yeah, not that long ago, yeah.
Yeah, it was a great conference, a little bit smaller than it usually is. I don't know, have you been to SQL Bits at all?
That was my first SQL Bits, but I had a really good time. The costume party was great. Overall, it was my first time. It was for my first time in Newport and Wales in general, so it was a great experience.
Yeah, the vibe is great. And I look forward to next year's one, and hopefully we can meet again there.
Yes, that'd be fantastic.
So I don't know, your talk was kind of around the topic of open data engineering, or I've kind of coined it that, but data engineering using open source technologies. So I don't know if you want to give both myself and the audience a bit of a high level introduction into what these technologies are, what they serve, and what people can do with them.
Awesome. Okay, so I'll take it from a couple different points. So first, we'll talk about sort of the labeling, like when you hear Apache, what does that mean? And then I'll kind of get into the specific technologies that would be relevant to data engineers, data analysts, data scientists, etc. So first off, when you hear the word open, there's open and then there's open source. So open source just really means that, hey, the source code's available for you to look at. And that's bare minimum, honestly, because at the end of the day, you want to know, hey, are there security vulnerabilities? Are they sneaking in spyware into whatever software I'm using? So having visibility into the code is really important. But there's something, but open goes beyond that. Hey, is there open governance? And then at the end of the day, who controls the direction that a particular open source code base goes in and what features it introduces? Who does it cater to? And this is where organizations like Apache really play a role in making sure that certain open source projects are community based. And the reason why that's important is particularly important for standards. Basically for example, imagine that your particular vendor controlled whether your form of measurement, instead of inches and or centimeters, you had thousands of different ways of measuring. How frustrating that could be. So having standards that are accessible to everybody really makes a difference in being able to communicate and really being able to build things. So the Apache Foundation started back in the 90s. So basically, the web was in its early days, and a group of people decided to create this software web server back in the days when there wasn't like just an off-the-shelf web server they used called the Apache web server, which is what most of the web still uses it as a day. But they realized that in order to protect the project and keep it sort of, safe, there has to be some sort of legal protection around like the trademarks, the code base, whatnot. So they created a nonprofit, the Apache Software Foundation, to be the owner of all the trademarks. So that way, um, no one involved in the project could just go and like sell the trademarks or just take over the code base.
Yeah.
And then they realized that they created this like legal structure, like this could also be useful for other open source projects. So not just in data, but just across technology in general. There's like a portfolio of like thousands of different projects now that have the Apache label. But there are other foundations like this. There's also like the Linux Foundation, but they do where they really differ is in the whole idea of governance. So again, Apache is really about open, meaning when it comes to a project, if they want to be an Apache project, they have to apply to Apache, become what's called an incubating project. And this means they have to prove that one, they have lots of contributors. Two, that those contributors don't all belong to like the same company. So that way you have diversity among the perspectives and sort of the interests of the people who are creating the project. And then that they have sort of like an open door. Like people can participate, people can communicate, people can contribute. And once they demonstrate all these things, then they get voted to be what's called a top level project. And then that's when you start calling it like Apache Iceberg or Apache Polaris or Apache. There's a whole bunch of them: Apache NiFi, Apache Hudi. It's endless. Now the difference is like Linux Foundation has a similar concept where basically, hey, we're creating this separate legal foundation to warehouse the trademarks and whatnot of a particular open source project. The difference is that it's not about a bunch of individual contributors with the Linux Foundation. It's about a bunch of different corporate sponsors. So it's usually like the Linux Foundations where you go where like there may be one or two or maybe three companies that want to share or want to work together on a particular open source project, but they don't want one company to own it. So they'll give it to the Linux Foundation, but like it's less about, hey, having a bunch of different individuals, a community that runs a project, more than having several different corporate sponsors. So it's a little bit more corporate steered in a sense. So while with an Apache project, like the people who make the decisions are individuals, and those individuals can switch companies. So there's oftentimes a lot of politics around that, where basically companies that want to have influence over an Apache project, they'll try to hire the people who are big contributors to a project because they can't pay for sponsorship. They can't go that route. They have to have the people. So it's community over code, the Apache way. And then again, if one company were to buy too many of the developers, the top level Apache board, they can actually clear out the board of a particular project. They can be like, okay, hey, we're kicking you all out. We're starting this over because this is going to be community based. So they're very serious about that, which is why when it comes to sort of industry standards, like the things I'm going to talk about, like Iceberg, whatnot, you want them to be Apache projects. Like that's when it really matters that you see that Apache name there because, hey, this is a thing that everyone can participate in. It's a standard that we can all sort of shape together.
Wow, it's not something that I've really looked into much before. I didn't really know there was much of a difference between the examples of Apache and Linux Foundations. I thought they ran very similar. It's something that I probably should have researched earlier on in my career.
I didn't know until I started looking deeper into it. It was just like one thing, like, okay, so like I knew they were both there, and I knew like Apache's the more open one, but how do you like express that? It wasn't until I started looking deeper into sort of like the rules and the way they work. They both serve a purpose. At the end of the day, like there's times where many different companies want to collaborate on an open source project, and Linux Foundation facilitates that. But it's a different. Essentially, they're solving a different need versus like, hey, creating open standards versus being able to facilitate contribution between businesses on a particular open source technology. So that way there's like sort of a neutral holder of the project.
That's a really good explanation. What's yours and Dremio's role in all of this?
Basically, the creators of Dremio are made up of people who are co-creators and major and founding contributors of projects like Apache Arrow and Apache Drill, Apache Calcite, Apache Parquet, which are all really key projects. So let me talk about those 4 projects first. And Apache Arrow is going to be the coolest one, but I'll save that one for last because it's sort of the hardest one to grok. But Essentially, there is Apache Drill, which was a query engine back in the days of basically in the later Hadoop era. So basically, there's this thing called Hadoop. Basically, people are like, hey, I don't want to store data in it's just a central database anymore. But a data warehouse on-prem, like a Teradata or Vertica, is too expensive. So how about we find a way to turn a bunch of cheap computers into a big hard drive? And Google comes up with this thing called Hadoop, where basically you say, hey, I got like 20 of these cheap computers with giant hard drives, and I'm going to network them and treat them as one giant hard drive. And that becomes the question is then how do you do processing on that? Like how would I find, because I have data, but the data is stretched out across 20 computers, how do I go get that data, run queries on that data? And there's several different answers to that. So first you come out with the actual Hadoop project comes out with something called MapReduce, which is basically an approach where you have to write Java to do that. Like I can't think of many data analysts who want to write Java to do their queries. So that wasn't very popular. And it was also really slow. So then a couple different other projects kind of come out. There's Apache Impala, which I know a little bit less about, Apache Drill, and Apache Spark. These become sort of like the three sort of like next generation of engines trying to address how do I run queries on Hadoop. Now another question then becomes sort of how do you represent data in memory? Because what happens is that every query engine has to load data from the hard drive into memory to do the processing, into the RAM. Okay. Now the question is, how do I do that? If every engine's doing it differently, then what happens when engines talk to each other? There's this constant having to repackage the data. So it's kind of like, hey, it's like using it's like using Google Translate. If I talk to you in one language and you talk to me in another language, and we're constantly using Google Translate, there's this time that we lose in having to do that translation every time we talk to each other. So it's much easier if we talk the same language. So that's what Apache Arrow does for in-memory data. So once you've loaded the data into memory, Arrow is supposed to be like that standard language. So those were the sort of the two core innovations that kind of came out of the people who ended up creating Dremio. So like Tomer Sharon, who was from MapR, was very involved in the Apache Drill project. Jacques Nadeau, who was the other co-creator of Dremio, was one of the co-creators of Apache Arrow. And then they founded Dremio, which kind of combined these technologies into a new engine called Dremio. And now Dremio itself is a proprietary code base. Like there are open source parts of it, but nowadays the platform has grown that a good chunk of it's not open source, but it's built on open source components. So it's built on Apache Arrow. A lot of its core bits came from what was learned with Apache Drill. Now, when you build a SQL engine, especially in Java, there's a thing called Calcite, Apache Calcite, and that's, for example, when you write a SQL query, that SQL query actually has to be chopped up into bits. So that way the computer can understand it. So that gets turned into a query, turns into relational algebra, and then that gets turned into like a plan for the computer to actually go get the data for you. Now, again, if everyone has to rebuild that every single time, that's just wasted time. So Calcite's like a standard tool for that. Like, hey, if I want to build a query engine in Java today, the actual how do I parse a SQL and turn that into relational algebra, Calcite's like a basically open source off the shelf thing I can pull to do that. So all these things are used to put together Dremio, and then that's kind of how it starts and evolves from there.
Outside of Dremio, then, are there any other kind of larger technologies that the general person in the audience will have heard of that also use these technologies in the backend?
Yeah, I mean, especially Apache Arrow is being used in like everything nowadays. Apache Arrow's, like it's like Dremio was a big part of the early days of Arrow, and it's kind of amazing to see how far that's proliferated. So like when you think about things like there's DuckDB, and DuckDB does a lot of things that are similar to Arrow, but they put their own little spin on it. And then there's another engine called Data Fusion that's becoming a thing. It's kind of like a DuckDB, where it's like this just off-the-shelf engine that you can just throw in the middle of a Python script. But it's not quite as smooth as an experience as DuckDB yet. But basically, Data Fusion is becoming the core of a lot of different products. So I know products like Spice AI, BioPlan, several other, InfluxDB. All of them are using this Data Fusion engine under the hood because this is open source engine built on Apache Arrow to do a lot of the processing nowadays. So that's becoming a lot of times you don't even realize you're using Arrow, using a lot of things. Snowflake has added support for what's called ADBC. So ADBC is like the new version of JDBC, ODBC for analytics. I mean, that's all came out of the Arrow project, and everyone's building their ADBC drivers nowadays. And there's a company by the name of Columnar that's basically trying to really focus on adoption of ADBC as a standard way we connect to our data sources going forward. which is actually really cool under the hood. Like it's a really cool thing to look into. But um, Arrow is really probably the one that the Arrow and Iceberg, but I haven't talked about Iceberg yet. But Iceberg came a little bit later on. But Dremio embraced Iceberg fully, but it wasn't created at Dremio. It was created at Netflix. So what happens? You had a bunch of data engineers at Netflix who were facing a problem. They were using that thing called Hadoop that I mentioned earlier, and they were suffering a lot of the same problems that many had felt with Hadoop, where things were really slow. Queries queries would take days on petabytes of data. So in that case, they wanted to figure out how can I scan this data faster. And before Iceberg, you would generally store all your data as Parquet files. So Parquet files, in the same way that Arrow is a standard for how I load data into memory, Parquet is a standard for how I would store the data as a file in a way that's really fast to load.
I use Parquet quite heavily in my job. We use Microsoft Fabric at the moment.
Yep.
Quite strongly, and obviously Parquet is a big underlying storage technology of the data lakes behind One Lake and things like that. But we found our own problems with it, and we have looked at and potentially tried to implement certain technologies outside of Fabric that can help us with processing of large data sets. So
yes, and that's exactly where a lot of the focus and a lot of the innovations are. So first Parquet comes out, and Parquet is still advancing and changing and improving every day. Like these projects are not static.
Yeah.
But I mean, Parquet before Iceberg, before Delta Lake, before Hudi, the way you would just actually save the data as raw Parquet, and you would have to keep track of folders of Parquet files, and it was really slow. You didn't have like ACID guarantees, so if you wanted to update the data, there was no safe way to update the data. So Netflix was like, okay, we need to solve this problem. So they figured, okay, right now the way Hadoop works is there's a thing on top of Hadoop called Hive, which tracks sort of the data you have in Hadoop, and basically says, okay, hey, you have a folder called sales. Any Parquet files that are in there, or JSON files or CSV files, any files that are in there, we'll treat them as a table. But the problem with that is that if you just treat the directory as a table, then there's nothing tracking what's in the directory. And that was sort of the problem with that sort of approach. So basically the big innovation with like Iceberg, Delta, Hudi is that they moved from saying, hey, this folder is a table to saying these files are a table. Because now if I know which specific files are a table, I can have many files in the same folder that are from different versions of the same table, and I'm not going to scan all of them every time. I'm going to scan the ones for that specific version of the table because I have that specific list of which ones are for that specific version of the data. And that was sort of the big transformation. Now, how each of them did it is a little bit different. If I'm right, if I remember the history, Hudi comes first, and then Hudi, basically what they do is they design like a timeline system where basically they track all the changes to the files of the data, and they track those changes on a timeline. The reason for that is because they were doing streaming. Like this was created at Uber, and they were trying to solve how do I handle a lot of data coming in really fast and still be able to run analytics on it for my data lake. And again, the data lake, think of it as just your object storage nowadays. Okay, so so your S3s, your ADLSs, etc. Now, how do I do that? So the idea is if I have a timeline, if I know exactly the millisecond that everything happens, then I can kind of just pull my query engine to look at that millisecond, and then it can rebuild the table based on all the history of events that happened. And that's essentially how Hudi works. Great for when you have a lot of data coming in and changing all the time. But not originally was not necessarily great for like just general purpose analytics. Like all of them have kind of converged, but then like Delta and Iceberg kind of come around the same-ish time, and they come out from different angles. So Iceberg comes out of Netflix. Netflix is trying to solve the problems we're having with Hadoop. So what they do is they create what's called a metadata tree. So they say, okay, hey, every time the table changes, we're going to have this top level file that says, okay, here, this is the description of the table, and these are all the different versions of the table. And we're going to point to another file that describes that version of the table called the manifest list. So basically what happens at the query engine, I go, hey, I want to query this table and I want to query this version of the table. It'll just look at the metadata, say, okay, I understand what the table looks like. Point me to the right version that I want to look at. And then it'll give me a list of files that are part of the table along with statistics that I can use to root out which files I want to scan. So there may be like 100,000 Parquet files that are part of the table, but instead of scanning all 100,000 files, I can actually look at the stats for each file and then weed out which files I want to toss out the files I don't need, because certain files may just not have data I need. So in this case, instead of scanning 100,000 files, I'm scanning 10,000 files. Okay, so that's the other big innovation behind these three formats, that all of them track metadata around the individual files. So it's not just a list of the individual files, but stats around those files to do what's called file skipping. So they can just skip scanning the file entirely.
Yeah.
Like Parquet does that at the file level. Like Parquet has these like row groups, and you can skip groups of data. But if your data is in multiple Parquet files, you still have to open up the Parquet file to examine those row groups. So if you can just skip the file altogether, that's even faster. So that's essentially like what's going on here. All at the end of the day, all that's happening is one, we're trying to track which files belong to the table and try to find every smart way we can to skip bits of data so that way we can query the data faster. Because the less data that I need to scan, the less data I'm pulling out of S3, which also one is going to reduce your S3 costs, but two is also going to make your queries faster and allow you to have data warehouse like speeds off your data lake for a much cheaper data platform altogether.
Yeah, you're making me understand that I've been taking a lot for granted.
There's a lot going on there, yeah.
These technologies, yeah. There's a lot going on there, much more than I knew. Like I know that a lot of these technologies within the Apache Foundation, they're all built for very specific purposes, and they can be layered or brought together to work on larger problems or provide larger solutions to or technologies. Which is one thing I've always found quite interesting about the Apache technologies, because I think when you think about modern software development or modern development of systems that is generally available to the layman, they're always like complete solutions of wanting to do this sort of thing. Like I mentioned Fabric, for example, which is the place for everything. And unless you're working on a lot of these in-depth problems, I suppose you could easily go most of your career without really getting into or understanding what these things are or why they've been developed in the first place.
Agreed. Like, for example, I've gone most of my life driving a car without understanding how an engine works. But hey, but when, depending on your particular role, if you're someone like a data architect who has to put these pieces together, then it becomes much more practical to kind of like have an in-depth knowledge. But also at the same time, for those just thinking from like a larger career perspective, knowing how these systems are built and knowing how they can be composed can definitely help you not just do what you're doing, but also be able to propose solutions that may not be obvious at different points.
Okay. So I suppose we've talked about Arrow, Parquet, a couple of other bits. You mentioned a couple of technologies called Polaris and Iceberg as well, which I think are quite important to this stack.
Yes. So again, Iceberg is the table format. So that's the one that actually tracks the version of the table and has a list of Parquet files and has all the stats. So
right. Okay.
Yeah. So Parquet. So basically, the way I think about it is Parquet has the data, and then Iceberg. So in the same, like actually, a good analogy is, like for example, I'm made up of a bunch of cells. Okay. Now I don't think of Alex as cell 1, cell 2, cell 3, cell 4, cell 5, cell 6. I think of Alex as Alex. So that consciousness is the Apache Iceberg table. So when I see an Apache Iceberg table, that's the sales table. I'm not thinking of it as Parquet file 1, 2, 3, 4. The Iceberg table contains the metadata. But there's a lot of people in the world. There's not just Alex in the world. There's Alex, there's David, there's many other people.
Yeah.
So how am I supposed to, when I think of like the phone book would have a listing of Alex, a listing of David, and where to find them and how to contact them. That's what a catalog does. And that's what Polaris' role in the picture is. So basically there's all these Iceberg tables that are sitting on my data lake. So because when I just look at my S3 or if I look at my ADLS, all I see is a bunch of Parquet files and some JSON files, and I'm not sure how all this like fits together. So basically, Polaris acts as a catalog. They'll sit there and say, okay, hey, these are the Iceberg tables you have available, and this is the current metadata file that you need if you want to access that table. Yeah. So basically, first and foremost, a lakehouse catalog like Polaris, which also would be something like a OneLake or a Unity if we're talking about the lake. Those are like more proprietary versions. Polaris would be like the open source, like, hey, I want to run it with the absent of whatever vendor I'm using version.
Okay.
But so it acts as like the phone book of all my assets on my lake. That's number one. But the problem is, I don't want anyone to just look at the phone book. Maybe I only want certain people to know where you can find Alex and certain people to know where you find David. So it also acts as the center of governance. That's where access controls would happen.
Yeah.
So a Polaris is where you would create like a user, and that user would then have like permissions granted to them. So now what happens, and this is where the data lakehouse thing becomes super beautiful, because now I could create, let's say I create a user called David who has access to all the tables in my Polaris catalog. You could go into Fabric, connect that catalog, and then you can see all the tables that are listed Polaris, whether they're on ADLS, whether they're on S3, doesn't matter where they're listed, where the actual files are. You could run Spark, run like a notebook on Fabric, query those tables, and basically what's going to happen is going to go to Polaris and say, hey, I want to access these tables. Polaris is going to check to see if you have access to it, then say, yes, you do. Here's the information. Pass the location of the metadata and credentials to access the metadata to Fabric and whatever engine's powering that particular notebook, and then access the tables. But then you can go separately run Spark by yourself and still connect to that catalog, or you could go connect Dremio, and then Dremio can connect to that catalog and then query all those tables. So the beauty here is that you have all your governance defined in one place, all your tables set up in a way that if you decide to change tools, like let's say tomorrow you decide like, hey, we're going to go do everything with Databricks, or hey, we're going to do everything with Snowflake, you don't have to move your data at all. You don't have to redefine all your access rules at all. You just have a different engine connect to that catalog, and they can see all your tables and run all your queries. And that's the beauty of the data lakehouse world. Like it takes a second to actually go build that out. Because it's not as, because at the end of the day, what you're doing is you're essentially building. It's like building most of the car or buying all the car's pieces separately and assembling it. But then the beauty is now you can stick any engine you want in there, and the car will run. So that's the beauty of the lakehouse. It's a little bit more work up front, but once you get there, you're future proof. Your data goes with you wherever you go, and the cost of switching providers or switching like how you access your data becomes minimal. You're not having to do a full migration. Like, hey, like imagine if you're using, let's say, SQL Server for all your analytics, and then tomorrow you want to go use Snowflake. There's this whole migration that has to happen where you have to move the data over, or vice versa. If you want to move from Snowflake using SQL Server for analytics, there's this whole migration of data that has to happen. If the data was an Iceberg, it would just be a matter of just pointing one engine to the catalog versus another one.
Wow. Yeah, I mean, that sounds amazingly powerful, especially in the modern day of, all these different solutions, all these different companies, all doing the same thing. People, I hear of people switching between technologies all the time, especially from an analytical perspective. I don't think I've ever really thought of migrating from one system to another to not have a data migration step to it.
Yeah, and I mean, here's even better. For example, let's say you have different departments in the same company. One department is using Synapse, another department is using Redshift. Now, sharing data becomes a big trouble, because now I had to give you access to this Synapse table, and you have to go migrate into your Redshift, and vice versa. Now that's a friction, but nowadays that's even worse because of AI. AI needs to have access to all the data for a lot of AI projects. So these kind of silos become much more problematic. So moving to a data lakehouse where instead, hey, one person has their data lakehouse that are Iceberg tables sitting on ADLS, the other person has a lakehouse with their Iceberg tables sitting on S3, all they have to do is give each other their a catalog credential, and they're off to the races. And no data has to move. Engines know how to read Iceberg. Engines know how to access the storage. They just have at it, and people can share data much more easily, even across companies. So basically, it makes it where the data access piece to accessing all your data for AI becomes a lot easier. So Data Lakehouse really builds a much more open platform, which AI projects need to be able to have much more full pictures of your enterprise for enterprise level AI projects.
Okay. It's just got me thinking. All that's got me thinking. But anyway,
oh yeah, it's exciting stuff.
That's by the way. Yeah, I mean, look, a lot of those, you're giving some really good real world examples there, which kind of really put these different technologies into perspective. And it's definitely something I'm going to go away and research more of. Maybe even have a bit of a read of one of your books.
Yeah. No, I mean, I have I have several books on Amazon.com. If you go to books.alexmerced.com, you can find them all listed. Find the right one. But I'll give you one piece more. I'll tell you how Dremio fits into that picture of getting to that lakehouse dream, because I think Dremio serves a really unique role in that. Because I mean, we see the benefit of getting to a lakehouse, But again, the migration challenge is a little tricky because there is still that final migration. One migration to end all migrations, but it's still a challenge because what happens? You have to kind of plan out how you're going to move the data. Now, chances are, like, depending on how you're doing it, your data currently, oftentimes you have to like switch how people are accessing the data entirely. So it causes disruption at every level.
Mm.
But with Dremio, you can minimize that. So what Dremio does is that Dremio is not only just like a great engine for querying Iceberg tables and data on your data lake, but Dremio is also a federated query engine, meaning that it can query data at other locations. It can query your SQL Server data, it can query your Synapse data, it can query your Redshift data, it can query your Snowflake data, it can query Databricks data in the Unity catalog. It can access your data anywhere. So the beauty is, what you would do first is you would set up Dremio and point Dremio to wherever your data currently is. Let's just say the example is SQL Server. Okay, so your data is in SQL Server, and basically you want to move it to Iceberg tables. What you would do first is connect your SQL Server instances to Dremio, and then you can model all your SQL views on top of Dremio. And now all your dashboards are already serving off the same data that's in SQL Server already, but they're not doing it through Dremio. Okay. So then what happens is that as you then what you do is you just do table by table. So you choose a table, whichever table costs you the most amount of money, move it to Iceberg. So now instead of everyone having to know that it's a downtime, they have to update their dashboards, all you do is you update the view. You say, okay, hey, that view that used to point to SQL Server.sales, point it over to Iceberg.sales. Then all the views on top of it are going to point to the new location. So that dashboard will just immediately shift being served from one data source to another data source because Dremio acts as an abstraction of where the data is physically located. So in that case, not only is Dremio makes it possible to access your data faster because it has a lot of cool acceleration bits we may or may not get into, but it also provides again that layer where basically the user doesn't have to care where the data is. So that allows you to get to allows you to develop the AI project faster because the AI project doesn't have to worry about, hey, is all the data in Iceberg yet? It'll benefit from when it's an Iceberg, because right now, up until it is an Iceberg, only Dremio can see all the data. But at least, hey, Dremio can be the access point for your AI projects to see all the data in your enterprise. And then once the data is an Iceberg, then everything can see all your data. But in the short run, you're getting most of the benefit up front.
Yeah, I suppose that really puts Dremio in a bit of a unique position, then, doesn't it, of enabling those sorts of transitions and making your data estate a lot more resilient to future change.
Yep. Basically, we serve as like, and I mean, this is probably, part of the reason why, for those who are unaware, recently, SAP has acquired Dremio. So, I mean, these are the kind of things that I imagine. Again, I don't know at this point. I've been told very little, if nothing quite yet, because the deal is just in the matters of finishing regulatory. But these are the kind of things that I imagine would be very useful for any large data platform and who would want to have Dremio as part of their platform to enable those sort of like, again, just to make it where the data engineers can focus on building the platform with as little disruption to the end user as possible.
Yeah, no, definitely. We slightly touched on your writing earlier. I've always been interested. I mean, look, I've started this podcast a couple of years ago. I've done a little bit of blog stuff myself, but obviously nothing in depth or technical like you've done. I myself am interested in getting into speaking gigs in the future, and I like to understand how people got started with these sorts of things. So I suppose what inspired you to start writing technical books in the past to kind of get to the point where you are now?
Okay, so I'll do the whole origin story, the shortest version as I can tell. Okay, but I'm gonna go all the way back to the beginnings because it all kind of connects in the end. Okay, so in the beginning there was the sun. No, just kidding. But what happened was like when I was young, I was raised by a single mom. So basically, my initial interest in technology was video games because that's what kind of occupied me most of the time. But then there was a period of time where, video games were awesome. But there was a period of time where I got one bad grade, and so video games were taken away from me for a period of time. And being a single mom, sometimes she couldn't get like babysitting or whatnot. So she was also going to school at the time. So she would take us to college with her, and she would sit us at the computer lab so we can just play around the computers until she was done with class. So that's where I started like playing with like GeoCities and doing like early stage web development, for those who remember GeoCities, and doing just pure HTML websites, and CSS wasn't even a thing yet. Everything was just inline styling. So that's how I get my early stages there. I also discovered something called an RPG Maker, which at the time wasn't officially released in the US, but there was a version you could get. And I started building like role-playing games. Like it wasn't coding quite say, but a lot of that like using variables, using conditionals, a lot of that was there. So that got me thinking in that way. And so basically that kind of, I ended up going to a special high school for microcomputer technology. I learned a little bit of C++ there. I started going to college for C++, and then everything changes. I decided I'm going to be a rock star. I grow my hair out. I switched to a communications major, eventually to a pop culture studies major. In the next 4 years, the rest of my college years are spent doing other things like running a comic book store and promoting concerts and all sorts of interesting things. Like you go to alexmerced.com, the whole bio is there. But that's where I started learning a lot about like marketing and the importance of community building and things like that. So I end up, so I kind of go on this whole sort of separate track than tech for quite a while. So I eventually end up going to New York City, and I end up working in finance. Nothing to do with anything, just random. So I end up actually training people in finance for the next 10 years, from 2008 to 2019. So 11 years. Basically there, that took me all around the world, training, basically anytime some foreign bank had their CEO wanting to move to the US or having to oversee a US bank, they'd need to get their licensing, and chances are they paid a lot of money per hour to have me teach them how to pass the test. The money didn't go to me; went to the company. But
Yeah,
I just got my salary. But come 2019, basically I decided that I was kind of done with that. Like I kind of had that, and I was trying to think what I want to do. I wanted to leave New York. I was just kind of, and this is right before COVID, so it was like perfect timing. So I buckle down. I get back into software development. I revisit all of my roots in technology, and then I do like a code boot camp and whatnot, and that goes really well. Like at the end of the funny thing is that by the end of the boot camp, so this is like December 2019, I already have a job lined up with a freelance agency to do like generally what'll end up being like a lot of Next.js, a lot of GraphQL, a lot of full stack development. But at the same time, the boot camp itself noticed that on the side, a lot of the other students weren't as familiar with all this stuff, so they were asking me questions all the time. So I would actually create video content for that.
In the boot camp, you created video content for the
other students. Yeah. Because my thing is I always did YouTube. Like even when I was in finance, I did a lot of YouTube. Like I have thousands of videos on economics on YouTube. So as soon as I started switching over to tech, I started making videos on tech. So they noticed that and they're like, "Oh, these are really good. You should be." So then they immediately hired me as an instructor. So now I have 2 jobs coming out of the boot camp. So I'm like, career change, successful. And then that brings me to January 2020. Okay, so January 2020, I have 2 jobs. They're both remote. And then 2020 plays out. That worked out pretty well. Perfect timing. But that year was really good. I mean, basically, I couldn't leave home. So basically, I spent that whole year just dedicated to sharpening my skills. So basically, that whole year, I learned Rust, I learned C++, I learned Go, I learned JavaScript, I learned Python, I learned Ruby, I learned all of it. And basically made videos on all of it. Like basically, again, I have a YouTube channel that has like thousands of videos on coding and all that stuff. Databases, like playing with like NoSQL databases, playing with graph databases, playing with whatnot. So that's basically my life for 2001. I mean, 2020 and 21. Now at the end of 21, I decided that I'm going to shift away from. I decided I want to look for something like a new role, and then I find out about this whole role called developer advocacy. And it's like, wait a second. There's a full-time role where you make YouTube content, you write blogs. I mean, all this stuff that I'm doing on the side for fun. Because at the end of the day, like, what was it? And the reason why that's relevant is because when I built like the comic book store and I did the concept promoting, that's where I learned the importance of like marketing and self-branding. So in that case, like when I was in finance, and then in finance, my boss would teach a lot about branding and the importance of your brand as a financial salesperson. So all of that kind of really sit with me. So when I went into tech, I took that with me and said, okay, hey, I need to build my brand. And that was always like a very huge focus for me. And that paid off a bit. So basically having this established brand at that point and having all this content, videos, blogs, whatnot, made it really easy to apply for these developer advocacy roles. It was like shooting fish in a barrel. But so I ended up with a problem where I had like too many different options. And I was, the question was like, do I still play it safe and stick to the web development side of things, or do I switch over to the data side of things and go to this company Dremio that showed a lot of interest? They end up convincing me to join Dremio, and I ended up joining Dremio. It was the best decision I ever made. And then basically the last 5 years, I basically have learned the entire, like, as much history as one should learn about the data space. I learned all these technologies, got hands-on with them, just really kind of just immersed myself in the world of the data engineer, to be an advocate for these, like, sort of this new architecture that was just sort of on the rise, data lakehouse. Because that was like basically like, hey, this data lakehouse thing is coming. We really want you to sort of go out there and advocate for it. Like most of my job the first few years wasn't even talking about Dremio. I was talking about data lakehouse, talking about Apache Iceberg, talking about Apache Arrow, really kind of selling people on the vision of what can be. And then that went really well. But getting to the fundamentals of the question, like writing a book, in that process we would do webinars. And when we did this one webinar on another topic that was really popular at the time called data mesh, where basically the idea was like, essentially the theme the last 5 years has really been, how do you create a decentralized data platform? Because I mean, data lakehouse, data mesh are all different ways of decentralizing your data, in a way. Data mesh is more about having lots of data all over the place, but just having sort of systems in place for people for different teams to kind of collaborate. While like data lakehouse is about having all your data in one format that all different teams can access independently. But it all ends up in the same sort of problem we're trying to solve. How do you make data more democratized, or accessible to more people? So this guy, he wrote a book with Manning. He did the data book, and then basically I noticed that when I look at the book, is that they're doing this interesting thing where basically you don't have to write the book all up front. They release chapter by chapter. So as he's writing the chapters, they release the book and they release the new chapters periodically. And I'm like, that's really interesting. And it's like, okay, I've been writing all these blogs on Iceberg. Wouldn't it be cool if we came out with a book on Iceberg? So I pitched the idea. I'm like, hey, how about we do this? And they're like, so then the thing was like, okay, well, if we're going to do it, how about we try to see if O'Reilly's interested? So then I reached out to O'Reilly, and that came to fruition. So they're like, okay, they were interested, we were interested. So then started the process of writing the book, and I wrote the book. That process took a year for the three of us to write the book. But the cool thing is, like, again, at this point, Iceberg Lakehouse is still just sort of like this not really a thing. Like, it's a thing, but not the thing it is now. So the first big pillar to fall is that eventually, like, Snowflake, getting the pressure from Databricks, realizes, okay, it can't ignore Lakehouse anymore. It can't just be a purely warehouse company. So its first step in that direction is that it announces it's going to support Iceberg and really have like good support for it. Start building really good support for Iceberg. So everyone's like, what's this Iceberg thing? And when they start doing Google searches, pretty much most of the content you find that was accessible. Like, there was a lot of content of people talking about their individual implementations, was very technical. Most of the accessible sort of, hey, I'm content created for people to learn was stuff that I had created. So it created this huge surge of all the content we created at Dremio. And then that was when we released the early release of the book. So it was like perfect timing. So suddenly everyone was downloading that early release copy of the book. Yeah, it gets even better. So basically over that year, basically between sort of like every company kind of agrees, like Dremio was kind of like one of the first to really kind of have that vision, realizing, hey, if Iceberg is the winner, then you have a market, because then you have this one format that is community driven that no one has control over. Because the alternative was Delta Lake, which Databricks has, it's a Linux Foundation project, but really it's Databricks that steers how that format evolves. So everyone in the industry kind of got behind Iceberg, realizing, okay, hey, this is the wedge to keep the industry open, to make sure that, hey, Databricks doesn't just control everything. So basically what happens is that Databricks starts feeling the pressure, getting people saying, like, well, I'm hearing all this stuff about openness and Iceberg. What are you guys going to do about Iceberg? And they didn't really have any Iceberg support at the time. So they needed to figure out what their Iceberg story was. And so they figured, okay, well, why not buy the people who made Iceberg? And the people who created Iceberg at the time ran this company called Tabular, which was like this company that was just trying to build this like company that was a catalog as the product. Okay, so basically you're paying them to have a Iceberg catalog that has all these like features that make it really easy to kind of run your lakehouse independent of whatever
Polaris section.
Correct. Yeah. So Polaris kind of is one of the things that ends up filling the gap that gets left behind by their acquisition. But so basically, I mean, Snowflake was interested in Tabular and was making offers, and I don't know anything for like facts. All I know is like what I hear through the grapevine. But I think like so basically ended up was like, okay, hey, we want to buy you for like $1 billion, and then Databricks was like, no, because I mean, of course, if Snowflake bought Tabular, Snowflake would have the strongest Iceberg story because they would have the creators of Iceberg, they would have the premium catalog for Iceberg, and then there's Snowflake. So Databricks is like, well, we need an Iceberg story, and we don't want Snowflake to have that story. So they're like, we'll buy it for $2 billion. It was like this small startup that was, very, very cool product, but they were only maybe making like, a handful of million a year as far as revenue goes.
Yeah.
And they so they get this huge purchase, like one of the coolest like lottery tickets I've ever seen, like ever, like fully deserved. Like Ryan, Dan, Jason, like they fully earned that. Like that they took that from the creation of Iceberg to where they are at now. Amazing. But that ends up creating another huge surge of interest in like what is Iceberg, and that was the week that the book comes out. So like a year later, it just works out that when the early release came out, Snowflake made an announcement, and when the book came out, Databricks makes an announcement. So basically that's kind of like what ends up sort of building like this. So it just worked out that I had like the way I think about it is like I think of myself as Iceberg's loudest educator. Like I'm not one of the open source devs. I've made like a commit to the Iceberg code base. I know how to write code. I've created libraries around Iceberg, but I'm not part of like the development team. But when it comes to like, hey, going out there and telling people about Iceberg and educating people about Iceberg, I would say I'm the loudest. I don't know if I'm the best, but I would say I'm the loudest.
Experience.
Thank you. But yeah, so that's kind of like my origin story and how I ended up kind of occupying the space that I occupy now. But then Polaris became a thing. So basically, what happens that as Databricks comes out with Unity catalog, and then Databricks buys Tabular, which was going to be Snowflake's answer to Unity catalog. Basically, Snowflake was like, okay, well, we need to make a catalog. The best way to outdo Databricks is always the open story, because that's always like sort of like the crack in Databricks' armor. So Snowflake, to their credit, has really done a good job of kind of getting behind open and the open message, more so than they were before. Like it was a really good transformation. So they're like, okay, well, we need to build an open source catalog, and then there were some mutual connections between Snowflake and Dremio, and Dremio had already come out with an open source catalog in something called Nessie. So they're like, okay, hey, let's talk about what we can do together. You guys know how to navigate the open source space, and we need to do this strategically. So let's work together, and we created Polaris. And so Apache Polaris becomes a thing, and then basically I end up writing the book on Apache Polaris. I still put out a lot of content on Polaris. But again, Polaris, you think of it as like, again, that neutral vendor. Now it's an Apache project, so everyone's contributing to it. But it's that sort of vendor neutral phone book of your data on your data lake to your open Iceberg tables that are all a bunch of Parquet files with your data in it. So at the end of the day, like it all is Apache down the hood, and it's all open, and basically offers you sort of the most flexibility of your lakehouse when you really embrace that sort of open stack.
Sounds like an incredible journey.
It's been, I know, right? Like I have to say, like one of these days I need to write the book. I need to write like the autobiography book.
Yeah.
Like I thought, like in 2020, I had already felt like I used to say like there's a bunch of other stuff, like there's this whole foray into politics. That's a story for another day. But in 2020, I used to say like, okay, I've had a good story at this point. If like I were to die, I feel good enough that I leave behind a good story. And then so far the story has continued, so I can't complain. It's been good to me. So if you go to alexmerced.com, you can find all these links. Yeah. But my Substack would probably be the thing where I do a weekly newsletter on what's going on in these open source technologies, these open source lakehouse technologies. And then I also do a weekly newsletter on what's going on with AI. So like, hey, what's new with semiconductors? What are the new models that were released? What are the new standards? So like, what's new with like MCP, agent to agent, all these kind of things. So that way, hey, with these two things, you know what's going on with the lakehouse place, and you know what's going on with the AI space for a quick shot in the arm as far as what's going on. I also try to write some like interesting, thought-provoking pieces. Like yesterday, I wrote a piece about AI and art, and sort of like the tension between AI and art, and sort of like what's the optimistic point of view and what's the pessimistic point of view. I tend to be an AI optimist. And I based the article off a lot of my experience that I've had recently. Because I used to be, like I said, I wanted to be a rock star. So I have all these recordings of me like playing these songs. You can find them on YouTube. If you look up Alex Merced guitar, you'll find all these songs of me playing.
Yeah,
But they're rough recordings. Like they're just recordings with like a phone camera or some really bad equipment. So they don't sound great. But what I've done is like there's this thing called Suno, which is like AI generated music, and they allow you to like upload a recording and then reimagine it. So I've uploaded like recordings of my old songs and be able to hear all my old songs as if they were like full throated production. And like, it gets you excited to write songs again. So I'm like, hey, look, this hasn't hurt my creativity. This has actually reawakened my want to be creative. And I find that my use of AI has allowed me to be creative in ways I've never been creative before. Whether it's visually, be able to take my writing even further, etc. Like I've been able to leverage AI to be more creative. At the end of the day, but at the same time, I've seen the effect that it has on a lot of artists who would make money not necessarily on. It's not so much that affects the money they make on making their original songs. Like if their original songs are popular, like the way you connect to an original song has nothing to do with how it was like the creator.
Yeah.
What I mean by that is if the song's I connect with that song because I connect with that song, and sometimes it has to do with the artist, and I like the artist's story, why not the human connection. But oftentimes, like if the making the money out there, that part hasn't gone away. What's changed is the things that people would do to pay their rent. So basically, the less creative things, like hey, creating the commercial jingle, doing copywriting. I've seen copywriters really have a rough time going through all this because you can really clean up your writing work pretty easily with AI. Doing custom logos, things like that. These are things where it's less like the artist trying to create their expression that they want the world to recognize, but more, okay, hey, this is what I do to pay the bills. That's where they're getting disrupted. And it's like, okay, well, now I can't do art full time. Doesn't mean they stop making songs or stop, painting or stop writing, but now the sort of more marketable thing on the side is kind of gone. And so there's two sides of the coin. Like it's allowed more people to be more creative in new ways, and that's a good thing. I think if more people express themselves, we all become nicer. Because oftentimes when you think about like people getting angry and people getting frustrated, people getting just like tense, it's because they don't have an outlet. But now you can find ways to express yourself more than ever if you want to, if you're looking for it. And I think to me that leads to a more socially cohesive world.
Yeah. I've become so much more creative and been doing being able to explore so many more technologies and ways of working.
Yeah.
Since AI's come out, I use AI every day for the work that I do, pretty much all the time.
100%.
It's just allowed me to really kind of step up my game and take it one step further, while at the same time still controlling its output, still having it as more of a tool for my creative outlet rather than making a load of decisions for me.
Exactly. It's a tool. Like for example, if someone makes a bad painting, I don't blame the brush. I blame the artist. The same thing if someone creates like what we would call AI slop, just poor quality AI generated stuff, I don't blame the AI. I blame the person using the AI because they're not putting the effort to make something better. Like I've seen amazing things to those who want to use the tool as a tool versus those who just use it as a microwave. Okay, I can make something quick, like at the end of the day, like there's a microwave, I can make food quickly, but I still enjoy food. Yeah. Oh no, go for it. But I still enjoy food cooked by a chef. There's times where I need something quick and there's times where I need something right.
Well, just one last thing then, just I suppose coming off all of that writing, the blog posts, your story, that community that we mentioned right at the start, the Data Lakehouse Hub. I think it's an important thing to end on to say, to talk about the community in general, not just Data Lakehouse Hub, but SQL Squared. You mentioned SQL Bits. There's communities around all the technologies that you've talked about today. I want to get your opinion from someone that leads in that area. What's your opinion on tech communities and kind of what makes them really special?
I always say there's different types of communities. So there are some communities that are sort of like the Data Lakehouse Hub community. It's more of a community around a particular technology, and usually those kinds of communities tend to be made up of practitioners who are looking to learn from each other. Then there's like sort of like the more general, like let's say like if I were to create like a specific like data community, then that honestly the angle there would be more of a community who are oftentimes more career oriented. Hey, you're looking to network for your career. You're looking to, learn things that are to keep up with the trends, so that way you're sharp for your career. And then the reason I point this out is just because it also affects what kind of programming if you're the manager of the community, what kind of programming you want to provide. It's very rare that I see a community of people who just are people who are like enthusiasts, purely enthusiasts, and they just want to talk about the technology. I'm excited about the different ways you can use it. You see it with certain technologies, like particularly technologies allow you to be creative. But usually with like more professional, like, hey, this helps me get work done, it's going to be more like, okay, either, hey, these are people who are in the space who are looking to learn each other to use the technology better. They're looking to network to build their career. Or if it's like a user group, it's a very specific technology, which is also trying to learn, but then that's a much more, like if it was a Dremio user group, it would be people who are existing Dremio users looking to learn from other Dremio users. And that can be a harder, and that's the thing, like most DevRel people, that's the community they're trying to create. That's not always the community you should create, because it depends on your product. Like, hey, if you don't have thousands of users, maybe that's not the right place to start. So, for example, like our focus was being not necessarily maintaining a Dremio community, but being a strong steward of the open source community. Just because Dremio has such an open source DNA in the things that it uses, the components that are built inside of it, and its contributions back to open source, that we wanted to make sure that we are a voice in that community, and that was a lot of our focus. Now, I mean, personally, the Data Lakehouse Hub is basically the little home that I have, where basically, hey, it's separate from my role at Dremio. It's separate from my role and everything else to geek out in technology. So for me, I am an enthusiast and I like geeking out about the details and like learning. I do enjoy putting out the learning, like, hey, what is a pull request that's coming out next week for Arrow, and like what are they changing and why are they changing it, and like why, if you rearrange bits this way, it's going to allow you your performance to be 30% faster than if you do it this way. But again, you have to recognize that the vast majority of people have lives, have families. So when they participate in communities, there has to be a little more than get out of it than that. Like, in a sense, like there's the people like me who will enjoy that, but there's a grander number of people who need, either like needs the learning to be the other piece of the community, to be the reason why they participate.
For the audience, listeners out there, please make sure to visit all of the community details that have been mentioned in this episode. And make use of local meetups near you to learn more and accelerate your career. All the links to the items discussed will be in the description. Alex, I truly believe that the descriptions you've given today have been, a masterclass in teaching me and the audience about open data engineering and the technologies that provide these sorts of solutions. And thank you so much for helping us navigate the tip of the iceberg today, to put it that way.
Love it.
And showing us what's truly possible, really, with modern lakehouse architectures and the platforms that come with that.
Thank you so much.
Just to reiterate to everyone in the audience, please visit datalakehousehub.com to find more about the community that Alex has mentioned, and a lot of the blogs that he's written as well. And as we've gone over already, but Alex Merced, Coder, on YouTube, to follow his YouTube channel. I'm sure you'll greatly appreciate that.
Yes, thank you. Yes, so please, and you can find the links to everything at alexmerced.com. So yes, you find there, and you'll find absolutely everything there.
Yes. And a massive thank you to everyone at home. Just like the Apache projects we've talked about today, we and I rely on a strong community to thrive. SQL Squared relies on you tuning in, and all of the content that we try and put out is very much geared towards things that can help you thrive as well. If you're experimenting with Iceberg, Polaris, or Arrow yourself, or you just have questions for me or Alex, write those thoughts in an email and send them over to mailbag@sqlsquared.co.uk. Please make sure to hit that like button, subscribe, follow, and turn on notifications so you don't miss our next release. And be sure to check out sqlsquared.co.uk to catch up on any other recordings that may be of interest to you, and obviously all in the playlist linked on YouTube. So thanks again to everyone, and thank you, Alex. Have a great rest of your summer, and enjoy the rest of the World Cup over on your side of the pond.
Yes, thank you. Thank you very much. Thank you for having me.
Cheers, Alex.
Cheers.
Bye-bye.